Okay, here we want to take another look at the limit comparison test. So once again, if we use the nth term test here, it would be inconclusive. If we use the ratio test, it would be inconclusive. And you can try these out to see. This is not a p-series because it's 3 to the n power, not n to the third power. So this is not a p-series, so that doesn't apply. So we have to see, okay, what does this look, what does this resemble out of all the tests? So let's look and see if it resembles now from here. This looks closely like a geometric series, but remember the original series here, this is not a geometric series because of that 4, all right, but it closely resembles one. That's the purpose of the limit comparison test. So now when we look at the geometric series, we can look, and if we look at this, our common ratio here would be 1/3. We know that's less than 1. So this series converges. All right. But now, since we still can't say for sure about our first original series, we have to look for the limit to confirm it. The limit once again, when we divide by a fraction, we know the old rules. We must multiply by the reciprocal. Okay, so we know here that the 2's are gonna cancel. Even if you multiply them across, that would have been okay. So we end up having 3 to the n over 3 to the n plus 4. As n approaches infinity, this is going to end up being 1. And once again, 1 is a positive number and it's a finite number. It means it's not infinity. So under those cases, and you can go back and look at the notes for the limit comparison test, we know that our original series converges. So basically, we're looking for the closest series that resembles it, because the limit comparison test is really made to compare our given series with a closely related series, all right, because it's not a true p-series or it's not a true geometric series. But when we compare it to those and we apply those rules, then we find the limit of those. We can make sure that ours converge as well or diverges.